December Denver Code Club meeting. Have any of you not been here before? I think everybody has. You haven't? Okay, I'll give the little spiel. So, welcome to Kenzon. We are a software consulting company specializing in transforming our clients' digital infrastructure. So things like from on-prem to cloud, monolith to microservices, that sort of thing. So, I'm Bill Schwanitz, I'm a TA here, so if you've got any questions about what we do around here, feel free to ask me. A little bit of housekeeping. Tonight's presentation is going to be on LoopBack 4, we'll get to that in a second. On January 17th is our next meetup. It's going to be, I think it's about the 5th installment in a series that we did on taking a front-end, back-end service from inception through deployment. So the upcoming one in January is going to be on CI/CD, continuous integration, continuous deployment, if you didn't know what those were for. And no need to have been to the prior ones to come to that one. It'll sort of stand on its own. So, without further ado, I wanted to introduce the LoopBack 4 presentation with Craig and Jake.
Thank you, Bill. All right, so just a quick agenda here. We're going to cover a little bit of history, a little bit of Node, a little bit of doing APIs in the Node setting, as well as sort of the quick history of LoopBack. Then we'll get into a more recent version of LoopBack, version 4. What is it? Why do we use it? How do we use it? We'll go over some of the key components of it. If you happen to be using version 3, we'll kind of cover why you might want to upgrade, as well as some interesting developments they've been doing with GraphQL. And then we'll do a little demo and do a little wrap up. So that's the plan. So in case you're unfamiliar, Node was released way back in 2009. Basically JavaScript on the server, it's just to make network applications. Single-threaded. It's the event-driven model to handle asynchronous code, which just means that it's fast. But because it's single-threaded, it can be potentially expensive to do computations, so that that's why you might pass them off to maybe Java or something that can handle a little heavier workload. But generally, it's considered an advantage to be single-threaded, just because it's a low memory requirement, and there's no new overhead for new threads. So that's one more. There we go. I wanted to talk about the HTTP package of Node. So Node has a ton of these APIs that can hook into many features within a machine's file systems. But the most common one we see in Node is the HTTP package, and this is a quick example of that. I don't know, can you guys read that okay? Okay. So basically we're creating a request handler that's going to get run every time a request comes in, and then we create our server and pass it to that handler. And then we tell the server to listen to a port on the network. It's very simple, and it's very low level, which can be a little bit slower to develop with. So fairly soon after Node came out, we started seeing the Express package. It was released in January the following year, and it's more or less a thin abstraction of the HTTP module. It's hard to say fast. With utility functions like routing, error handling, and rendering. But the best part about it is the middleware. So basically it intercepts a request. You can do some processing before you pass it back to, as a response, to continue down a possible chain of more middleware. So yeah, it's a little bit faster. It's I don't know. It's imperative. So again, there's no real abstractions here. It's you basically what you want, you have to write out. You got to program yourself. so there's a great deal of flexibility with this method, but it does come at a cost. So you don't get things like, it's not super extensible. You can only really extend through middleware. There's no concept of state management, and there's I'm sorry, it's not composable. That's right. So the order of the middleware is determined by the order that it was written in the code. Basically what I'm saying is there's a lack of declarative support. Express doesn't care what you do with this code here. It just does a few things, it does them well, but you have to be specific with what you want it to do. Additionally, it doesn't have any concept of a database. So most modern applications these days are going to have some kind of data hooked up to it, but there's a lot of variables in the way that we interface with that data. So people at LoopBack said, wouldn't it be nice if there were a framework that could get you started with Node.js API development that facilitates connecting to a data source? So that's where this LoopBack framework came from. And it basically sits between the API endpoints and the backend resources, and it provides a model-driven API. So the idea is that LoopBack becomes the source of truth for all of the data in the application. So yeah, just again, it's a framework to help quickly create and manage REST APIs as microservices in version 4. And it uses the API, the OpenAPI standard. I think that was formerly the Swagger standard. So LoopBack's goal is to make it easier to build apps that require complex integrations. So it provides a variety of different extension types that you can leverage basically to connect any web client to data and services. So again, it just kind of sits right there in the middle. So we define models that are being used on either end of the request and the response, again, to be the source of truth. Just a little bit of background there. Strong Loop is a company that got purchased by IBM, I think, back in 2015. They were the ones that came up with the LoopBack framework way back in 2013. I think LoopBack 3 is still being developed. I think it's under active long-term support at this point, because in October of this year, a couple months ago, LoopBack 4 went to general availability. So that's now the default LoopBack if you go to start a new LoopBack project. Yeah, a little slow. Okay, quick look under the hood. LoopBack leverages the MVC pattern. This is a change from the previous architecture. There's no actual views here, so the V is silent. There's just controllers and modules, or models, sorry. So one of the other things they wanted to focus on was testing as a priority. Because it's so modular, because it is very extensible, testing in isolation becomes a lot easier than it used to be. So that they feel like that's a very important selling point for people interested in version 4 that might have dabbled in earlier versions. So it still uses some familiar technologies like Node.js, so it's pretty fast. It now uses TypeScript. If you don't know, that's just a strongly typed superset of JavaScript. It'll compile down to plain JavaScript, and it offers some newer features on top of like ES 2017 and like interfaces, which are going to enforce some of the strong contracts. That's right. Promises become first class in version 4. Before it was relying mostly on callbacks, but you could use promises. They're just kind of awkward. Now await and async are front and center, so that's pretty refreshing. It still uses Express under the hood, primarily for middleware, because loops, so many words. LoopBack is basically has its own routing engine. So it wraps around Express. And this is what allows LoopBack to be extensible, but still leverage some of those middleware features. The long and short of this is that LoopBack is now, it affords composition by convention and some more popular design patterns. And the last thing is it also uses the OpenAPI spec, which we talked about, which is really just a description of your API. So why should we use this? Like I said, it becomes the source of truth for those data models. It's that API composition layer, so where Express is imperative, LoopBack provides a standardized API composition layer. We have that strong typing from TypeScript from end to end. And again, that OpenAPI standard, which we also get to benefit from using the Swagger UI, which is like free documentation. I think we'll get to that later in the demo, but that's also really nice. It's extensible, so again, core feature. You write your own reusable components or leverage ones from the community. It's just drop it in. It's very easy. And lastly, it's modern JavaScript. It's TypeScript. We're using ES modules, first class promise support, and again, ES 2017 features, among others. So quickly, just why might you upgrade from 3 to 4? Version 3 had the option to serve client code. If you set it up that way, then you could. However, it kind of contributed to a monolithic structure, so they started to get away from that, and it's much better suited for microservices. The V3 had a different model idea, and a lot of the responsibilities for those models were kind of just put under one umbrella, which meant some of the code that wasn't necessarily related was tightly coupled with other code. So version 4 will break this up into different pieces, namely controllers, repositories, models, and services. I'm just going to warn you now, there's a lot of different terms like this, so just bear with me. I'll try to get to the most important ones. Like I said, promises were an afterthought, but now they're front and center. And there's this concept now in version 4 of the inversion of control container, and this plays into the whole dependency injection thing. Basically, the LoopBack team is trying to apply some of those tried and tested design patterns and avoid falling into some of the pitfalls that they got into in version 3 that because they weren't using these. Just became kind of a spaghetti code mess, and just extending it became a headache, and it became more having to know LoopBack specific information as opposed to just coding in JavaScript. So there's a couple ways we can use some of the tooling here. The first one we wanted to go over was Bottomup, which is more of a programmatic code-first approach. Basically, you're writing everything. You're not leveraging any of the tools that they have. This is important because you can just write code as normal. It's not stopping you from just writing as if this were an Express application, a little more complicated Express application. The other thing I wanted to mention here is the top-down approach, which is leveraging the available CLI. So you get to scaffold out an app or an extension and generate artifacts as you need them. If you're familiar with Angular, Angular has a very similar API, or CLI, I guess. There's a couple other ways that are also useful, I think. There's the outside in. These aren't actual terms, they're just making these up. I'm making this up, but outside in approach, which is really just taking an OpenAPI spec document and importing it into a LoopBack application. and it's going to scaffold out a bunch of endpoints and controllers and things for you, which is nice because then all you have to do is connect the dots and make things, talk to each other. But this is a pretty good shortcut. And then the opposite of that is the inside out, which basically, if you wrote out your entire application by hand, you're able to export an OpenAPI spec that you can take somewhere else if you need it. So a lot of flexibility there. Some of the documentation for LoopBack is a little confusing, so pay attention to just the context section here for now. Context is that inversion of control container. It's basically a service registry. It's an in-memory abstraction of state and dependencies. So this gives LoopBack more information inside of other components that they might be able to. If it's registered in the context, they can just go and grab this information. It's basically, I don't know why I think of it this way, but I'm going to say it. I think of it as like a cloud that sits over the entire application, and any component in the cloud, under the cloud, can retrieve information from it. So we'll get into this a little bit more in the controllers, but basically if you have different components here, you can bind to the context, bind information to the context so that the context is aware of these different components, and then later on in any other component you can inject or get that information in your controller or wherever you need it. So here's a quick example. So we've got two different files here. This is the application file. So this is kind of the piece that it's the stage, right? It's the thing that you'll bind all your controllers and repositories and every piece in at the controller so that it gets put into the context so that anybody can see it. So here is just an example. We're binding this logger widget, which is really just not shown here. It's a function. Log info is a function. So this is now part of the context. Now we go over the widget controller and we say inside of our class we want that logger widget, so we're going to inject it into this property here. There's a handful of different decorators that you can use to do dependency injection. Is one of them. We'll see OpenAPI examples. We'll see authentication examples. Basically, if you're not familiar, decorators are a design pattern. So this @ symbol here and inject, it's just a way to add more information to a class or a function or property.
How do you keep things from binding to the same name? Like if something else would.
So like if you had two logger widgets, for example.
Yeah, something immediately called bind logger widget again with
So-
something totally different.
I imagine, so because this is TypeScript, it has to compile. I imagine that when it compiles, it's going to know, hey, there's already a log info, there's already a logger widget.
So it's kind of like a set once. Like once you bind something.
I haven't actually done that, so I can't speak with any authority there, but that would be my guess. Otherwise, it's just going to overwrite the original one.
Okay, good.
That's my other guess. Right, so the application, like I said, is the stage. This is where we set everything up. We're basically extending the context in our own way by doing all of these bindings there. Related to that is the server. It's really just going to be starting and stopping and listening on a port and handling that information. It's fairly simple. LoopBack comes with a REST package that you can use, so you don't really have to write your own server. You could just leverage theirs. However, they do allow you to write your own server if you need really customized features in there. But I think it's, in most cases, you could probably just get by with using the default REST server. So the server just really represents like implementations for inbound transports and protocols. So REST over HTTP or GraphQL over HTTPS or gRPC or whatever. And I guess it's worth noting that you can have multiple servers running in one application. So here's an example of the application file. And because you can't see the imports are cut off, but we're leveraging this LoopBack REST package, and we're calling the super constructor here, passing in an object which has some REST options, which is for this package. So we're setting our REST server options up here, passing in the super, and then it handles it from there. Further down, this is where we're doing our binding. So app.component, app.controller, all these things we're registering inside of our context, and we're able to do our binding here as well.
So is the multiple server capability based on the number of processor cores?
Unknown. I'm not sure. The only example I can think of having two servers is one we're going to show later, which is having a REST API up and running, but then also a GraphQL server up and running at the same time, and they're talking to each other. And it's just, I mean, the servers just sit idle until a request comes in. So,
Well, you've got two a loop running, haven't you, in the server,
right.
essentially. So now you have two event loops running in one processor, or are they?
Yeah, so it's all single. It's that event-driven model. So everything's done with asynchronously. It's done in you know.
Standard node pattern.
Yeah, so it's they're not going to trip over each other. There might be, you know, if you might get into some data writing issues, maybe, but it depends on what you're doing, I guess.
Okay.
Yeah, I don't know if I have. Let's talk after, because that's an interesting thought. So yeah, this, any questions with this? This is this context is pretty important.
So does the context buy you some kind of, like, you mentioned these like APIs as microservices, does it buy you some kind of like health checking or monitoring or anything like that, or?
So because it's a cloud, it's a little mysterious. So when you scaffold out some of these applications, they'll come with like a health check information. I'm pretty sure it does get stored in this state in the context. I guess it's worth mentioning that you can have state for components. You can have state for multiple components. Like, it's not just this one giant cloud. You can have different contexts for different
Subclouds.
Exactly. Thank you. Yeah, exactly. So I imagine, yes, it's probably in there somewhere. Okay, so next is controllers and routes. These are sort of pretty closely tied together. Controllers are basically just handling your incoming API requests. It's that bridge between the REST API and the domain and database models. And it's just handling your business logic. The route is going to map the API spec to an operation. So when a request comes in, the route's going to figure out where in the spec this, you know, what function this needs to call, and it's going to go find the right method. Routers are just decorators, like we mentioned earlier. They're used in conjunction with controllers. So in this case, we've got the hello controller example, and here's our list method. It's async, and we're using the route decorator here to say anytime a GET request comes into messages, run this function. And in this case, it's going out to a repository and calling the find method. So basically, this is tying your app's OpenAPI spec to the routes. Next thing I want to talk about is repositories. They're just an interface. That's what provides that strong typing contract, and this is what's going to provide your CRUD operations against whatever domain model you're using. So here's just a quick example of a possible repository. They're not actual functions. They're just saying these are the methods that this is going to need. This repository is going to need. So setting up that contract. Next idea is the idea of models. And this is how we define those schemas for different business objects within the system. Examples would be customer, address, and order. And these can contain things like properties like name, types, and whatever other constraints, maybe some validation. But they're basically just used for that data exchange to make sure we're all speaking the same language. There's two different types. There's the value object, which is, there can be many of them, versus the entity, which there can only be one. Here's a quick example. So it's basically, it's a very simple class, right? It's got a couple properties here that have the property decorator, so that the model is aware that these are important properties and that it should know in the model.
Yeah, you have a question?
Yeah, can you define like required properties then and things like that would get caught in middleware? I
think so, yeah.
Yes, you definitely can. And so you would do that within the parentheses of the property annotation or the decorator there. You can say type, or you can define type. If it's required, if it's the ID.
So if there's like a post body getting sent that like didn't match like your source of truth in your middleware, would it get rejected then, just outright by the framework, or?
I'm not completely sure. I haven't encountered that scenario yet. But that's definitely something.
It's a concern.
That's definitely a valid
concern. There's also this idea of relations. So there's relation decorators you can use as well that will, has many or belongs to just kind of the typical database relations. So there's a couple more. I know there's a lot. They're not as important, so I'll just kind of skim through them. There's the idea of data sources, just name configurations for a connector instance. So it's an abstraction around like a specialized extension that just happens to interface with external data. It's components, which is their LoopBack way of saying this is not, it's not a part of the core LoopBack. It's a third party, package node module or something. Services, this is just a way of interacting with outside services or other data sources. They're just like repositories are specialized services. Last idea is sequences. It's really an extension of the Express middleware. Gets a little complicated, so I'm not going to go into a lot of details. And these aren't super important to know. They're nice to know about. Maybe look into them on your own time, but we're not going to use those specifically today. This is not all of the different pieces. I know there's a lot of them. There's a lot of new vocabulary thrown at you all at once. So this is just an example, a to-do list application example. Just maybe a little over-architected. For our purposes, it gives us a little bit of an understanding of how these things fit together. So you've got your controllers, which again, handling your business logic. These talk to repositories, which are the interfaces, to the model. So these are going to be your find, your create, your delete, whatever the interface dictates. And these are going to talk to the models. And here's the relation that we talked about as well. Here's just another instance of that. Does that help kind of put things in context a little bit? Maybe context is the wrong word. also the CLI we talked about. This is nice to scaffold out a brand new application or a brand new extension. You can also, so LoopBack likes to call all of these things we talked about artifacts, which is just yet another confusing term, but you're able to generate, it's Yeoman generator, so it's able to, if you select a controller, it's going to ask you a bunch of things to help set that up. It'll scaffold it out, and then you connect the dots. So we talked about GraphQL a little bit. If you're not familiar, here's just a quick summary. It's basically just a query language, just a specification for requesting data. Some of the benefits are you're not overfetching data, you're just requesting for what you need. You can get many resources in a single request, so you can have many queries in one post request. Very large community support, great tooling. It's language and protocol agnostic, so it's very flexible, and it benefits from a strongly typed schema. So one of the goals of LoopBack is to connect web clients to data and services, right? So LoopBack is that piece in between clients requesting data and the data itself. So it wants to be that source of truth. So if a client is making a request to a REST API in a LoopBack server, and LoopBack has the data modeled and it knows how to retrieve that data, how do we map that request to the model? And it's going to be this OpenAPI spec here. That maps the data models to the operations. So taking that a step further, if a client is making a request using GraphQL to a LoopBack server, and LoopBack has the data modeled and knows how to retrieve it, how do we map the GraphQL data query to the data model? And LoopBack's answer is OAS graph. They basically wrote a CLI that will take in an OpenAPI spec, translate it into a GraphQL schema. It's a really interesting white paper they did. They tested something like 900 different OpenAPI specs, and something like 89% of them actually worked really well. So that's pretty good odds of using this tool successfully. So now we have, instead of OpenAPI, it's effectively GraphQL in the middle of all of this, connecting users to their data. And we're going to show you in a minute, but the way this does this is very fast, and it's in order to get a GraphQL up and running, it's very easy and very quick. So this is pretty exciting. So why don't we do some demos? Let's swap here.
Yeah, we'll swap. Alright, we don't need that anymore. Nope. I don't know. Yeah, so let's go ahead and switch this. We're going to do some mirroring, because that's going to be a heck of a lot easier. But not like that, because that's unreadable. Share this whole screen. Cool. So I'm going to move that out of the way. Wow, I feel so disorganized. Sorry about that. We're going to go ahead and escape. So basically, we have a little bit of a repository. What? Why are you doing this?
The window's too large for the screen.
That makes sense.
With the green.
There we go. That's better. Can everyone see that okay? I can zoom in a little bit if you need.
So basically, we're gonna just kind of walk through how you get started with LoopBack 4. Pretty simple steps just to kind of get you going. First thing you're gonna need to do is npm-i -g loopback client. That installs all of the packages you need to run LoopBack, whether you're using the client or not using the client. Great thing is you can generate a base application in just a couple of seconds. Back to terminal. Sorry, I have way too many windows.
It's a lot of desktops.
Yeah, well, you know, it happens. So when you run LoopBack 4 app or LoopBack 4, it allows you to enter a project name. I'm going to go ahead and call mine Heroes. Project description, it's a apparently I can't type today. Yeah, you know what?
It's an API.
API, yeah. So the root directories can be called Heroes, and the application class name can be called Heroes Application. So it allows you to select which features you would like to actually enable. So we want TypeScript or TSLint. We want Prettier, which will kind of make sure we can clean up the way our code looks, formatting wise. Mocha for testing. It's got the loopback build. I am actually using VS Code, so I'm going to enable it to build right into VS Code. Repositories and services, which are both kind of key parts. And repositories are going to work in a little bit of a different way sometimes. So Craig had kind of spoken to the two different types of models. So you have the entity type, where there's only going to be one with a single ID, whereas when you have just the regular object model, you can have multiple that look very similar or the same object. And so repositories are really only going to work with the entity type because it allows it to have something to search off of. So we'll go ahead and let it generate that. Cool. So now we do have the project that was just generated. So we'll start with source. You have your application. Is that good for everyone to see? So generates all of this for you, your controllers, all of your bindings, and it even creates the, it comes with the built-in, sorry, I can't think of the term right now, the LoopBack Explorer, which is basically your documentation for your API. So right out of the gate, we don't have any models, we don't have repositories, don't have a data source, but it does generate a simple controller for you, which is just a ping controller, which you could use for like a health check or whatever you so please. So I guess what we can do is go ahead and just start this up. Oh, might have to fight. Sorry, guys. You know what? Nope, not ready yet. So that's going to spin up for you on localhost 3000, and it gives you the opportunity to look at both the OpenAPI spec as well as the Explorer, which is your documentation. So right now we only have the ping controller. It's going to tell you what kind of response you would receive for a 200. So
If you're not familiar with the Swagger UI, it's basically like Postman in the browser, and you
Yeah.
can just interact with your running server.
So if we do an execute on this, it's going to give us a response body of greeting hello from LoopBack, gives you the date, URL, all this information. I mean, that's a great start. You kind of have something to go off right off the bat. Now let's jump back in and actually kind of, no, that's, I should have closed down everything. So now we want to create a model of our own. So we could use the generator to create our own model just by running lb4 model. It's going to pop up, ask what we want our name to be. So we'll call this one hero. And as we said, entity is if you want to have IDs and use the repository. So for this example, we do want to have each hero have a different ID. So enter property name, you get to define all of your properties. So we'll just call the first one ID. Cannot contain. This is going to be a number just for simplicity's sake. Yes, it is the ID property. Is it required? Yes. We'll leave that blank.
This is nice because you don't have to use the ID as your unique value. You can use like an email address or some other value.
Now we're going to add a name, string. Yeah, that's kind of required. Then we want to say you have a friend. Not so much required. And we're going to add a planet, also a string, not required, and a species finally. No default. As soon as you're done, you just kind of do an empty one. Generates the hero.model.typescript file under your models, and it updates the index.typescript, which is what kind of ties it into your application. So now when we go ahead and look at our models, we have a simple entity. All of your properties are defined. They each have a type, ID, and whether they're required. Or if they're required, it sets required to true. So now we have all of the simple information of describing our model. It uses the constructor to actually kind of create your model. We need to have a data source before we can create a repository or really go any further. That you can also generate, which is awesome. Makes it really easy to get an application up and running very quickly. Data source name, we'll just call it DB. For sake of simplicity, we're just going to use an in-memory database, window local storage, key for browser only. We're not really worried about that. And for this, we're going to do /data/db.json. So it's just going to enter all, save all of our information in a db.json file. And so it's going to create two different files for you. You have the JSON file, which is going to describe what kind of connection it is, and then you have the TypeScript file that's actually going to tie that JSON to your application. Now we're ready to kind of take a step further and actually make a repository, which since we have this, we might as well use it. We'll do some modifications in the code afterwards once we have kind of the base app up and running. So repository, it's going to ask you to choose your data source. You could have multiple, but this one only needs one. So you just have to use spacebar, select your repository, the model you want to create the repository for, and now it has a repository that ties the data source to the model. And as we kind of saw in the example before, it is just using the default CRUD repository. So you don't really have to do a whole bunch of definitions for all of the methods to retrieve your data. That's just built-in functionality with LoopBack. Now we're ready to do a controller, actually have all the methods for this API. So do LB4 controller. We'll call this hero. And so you can do an empty controller and
just have it be there, or you can have it generate all of the CRUD functions, which is pretty convenient. So model is hero, and the repository is hero repository. The type of the ID is the number, and /heroes is great. So now we have a hero controller. It's going to pull in all of these methods from the repository. So you have a post, you have a parameters, you can get, you can filter your requests. It'll even count the number of heroes, and it builds out all of your logic for you. So now we have a working application that we can actually make requests to save data. So now we'll start it back up. Do a quick refresh, and now we see all of our new endpoints. So right now we don't have anything in our database, so it's going to return a count of 0. So let's go ahead and at least add a few heroes. So we'll do try it out. It'll actually update the ID for you. You don't really have to enter that. So we'll just go ahead and say we have Batman. He has a friend named Robin. He is from Earth, and he is a human. Execute, gives us a response. That's not cool. Internal server error. So let's go ahead and go back. I went too far. Still not in the right spot. Okay. Oh, that would be why. So I told it to point to data db.json, and I didn't actually create that. So it had nowhere to actually reach. So let's go ahead and create a new folder. We'll call it data. And in that, we'll create db.json. So now, if we run that same request, we should actually. It's still not liking that. You know what? I think I might have defined it differently there.
Do you need to restart the server?
That's what I did wrong. I figured it out. Trying to go too fast here. So, if we go back to source, and the data source should be good. Now we should probably restart the server because we changed that. Alright, now we hit execute, and we now see our hero has been added successfully. We can go ahead and retrieve by ID. His ID is 1. Great, we get the response body. So everything seems to be working there. We can update the hero if we want to. We can delete the hero. This will now return that we have a count of 1. We've got a basic API up and running now. So now if we wanted to make this a little bit more complex and have some more models than just your simple hero, we want to define an object for the hero's home planet. We can create a new model. this one will be called planet. It's also going to be an entity because we're going to have different planets and you're not going to have multiple of the same planet. So this will have a ID, number, yes, yes. We'll have a name, and that's all we really need. You don't need a whole lot more information about the planet, so we'll call that one good. And then we will go ahead and add a species. Some nice relaxing music to go along with the typing. So
It's like elevator music.
yeah, exactly.
Typing music.
So this one will have the ID. Yes, it's required. It'll have a name. And it will also have a lifespan. Would you be able to grab me a charger?
Yes.
Looks like I'm
I got
about
it, Jake.
30 seconds.
Do you have the new?
No.
Sorry.
Is there one at your desk?
There is one at my desk. Brian can grab that. Thanks. No. Shoot. I did that wrong. Sorry, guys. Lifespan, which will be a number, not really required, and no default value. So now we have a couple new models, and we're going to go ahead and look at how we can use some of the relations that are available to us in our models. So we're going to go ahead and actually update our hero model. So let's start with friend. So a friend is likely going to be another hero in this scenario. So rather than using this at property definition, we're going to go ahead and add the at has yes, belongs to. Thank you. Belongs to method. Trying to tie too many things together. Hero, and it's gonna do it. You know what? I have this in the README, and it's gonna be easier to follow along that way.
We have all this code on the GitHub repo, so if you want to take a look later, it's all going to be there. And we'll have links to everything in the slides as well.
Cool. So now, let me jump down to part 2. Planet, species. We added our step 2. Model. Here we go. So you're going to decide how you want to key this value. Key to ID. So now the hero will be keyed to by another hero. We're going to go ahead and do the same thing for planet and species, because I mean, you're not going to really have more than one planet.
You might have more than one friend, but let's not go crazy. We're developers here. We know how that works. So now our model is updated, but unfortunately that's not all of the work that we'll have to go into actually tying these together. We now have to kind of create the repositories to manage both planet and species. So we'll just go ahead and create some new repositories really quick. We can do planet and species, just run it once, super convenient. Now both of those repositories are added. It's linking your data source. Same there. But our hero repository is going to actually need to be updated. And the way we're going to do that, we are going to use a belongs to accessor. So we're going to add this public read-only friend, and it's actually going to tie it together for us so that we know that these are linked by the ID. So doesn't like to just do one. So belongs to accessor. There we go. This is actually hero. So now we have got the friend. We can do the same for planet and species. So they all will be linked by the hero's ID, not the ID of the friend or the planet necessarily. So this is species, and this one is planet. So now it's going to tie in those models into this repository, and now we have to actually use a dependency injection to actually use the getters to bring those repositories into this one. So that's actually not super difficult to do. So we'll start with the hero one. We're not going to add a getter to reach out to a different repository. We're just going to go ahead and retrieve from the current repository. There we go. Add that in. Pull some dependencies for me, and we will add a repository getter. So under the injection of the data source, add repository.
If you're not familiar with what he's doing, he's basically like retyping that item, and then it adds it in as an import.
It's importing
automatically for it.
Yeah.
When you paste in it doesn't do that, but when you retype
When
it,
you type it and hit enter, it does it for you. It's wonderful. Although it's frustrating, you have to do it that way. So we'll add the second one, and that will be planet repository. Oh no. I just want to be able to type from the front.
accept pull requests.
Except for. So we'll go ahead and actually add the method that will actually retrieve the species, and we'll go ahead and just duplicate that, make it easy. We can also grab the planet, or it does care about type, so it kind of verifies that I'm actually doing what I say I'm doing. Now we have our repository finished up. Let's go ahead and add
a couple methods to our controller so that we can actually retrieve that data. So made it easy here. So we're gonna have retrieve friend. And so the way this is going to work is it's still going to be using your same async await functionality, and it's actually going to just reach out to the character repository, and it's going to search for friend by the hero ID. And that's all it has to do. So it's not like you have to write a whole lot of extra logic just to retrieve based off of this. It builds it out really nicely for you. So we'll pull in all of those. Had to change the name. So species hero. So I'm just trying to jump through here and fix all these. No, it's not gonna return. Yeah, that is going to return a hero. And now we can go ahead and start this up, and it will allow us to go ahead and access this. Not computer start. Cool. We are up and running again. Page. So now we see the hero's ID friend. Shows your response. It's going to be another hero page. One thing I didn't do yet was actually update the data. So let me go ahead and just throw that in the database really quick. Made it easy and just some data for us. So db.json, goodbye. This is now hero. And there. And I think I got rid of this. No, there's not a character ID. No, there's nothing called character ID. Yeah. So now our database is updated. Let's go back to our. Don't need to. Should grab it automatically. So let's start.
Some excellent tooling.
Yeah, definitely is. I guess let's get our count first, just to kind of show what we have. Execute. Why are you doing this to me?
It's the JSON's formatted.
So I formatted my JSON correctly, apparently.
I'm expecting the end of JSON.
There we go. Missed a bracket. And so now we see we have 4 heroes. So let's go ahead and just we can start playing with this. So we'll start by just retrieving our first hero, which, as we saw before, was Batman. Now that doesn't seem right. Did what?
I guess it was the same ID.
Oh, I know what I did wrong. You know what? I'm getting sloppy here. I didn't follow my tutorial. Thought I could wing it. So now it's just going to have those ID values rather than the actual object, but we know that their friend's ID is 2, their planet's ID is 1, and their species ID is 1. Cool thing is with the endpoints we had, we don't have to go try and reach out to a API, or we don't have to try and find the friend by that ID. We can just go ahead and say, hey, we know our current hero's ID is 1, so we know his friend is Robin, who is ID number 2. We can go ahead and do the same thing for planet. Try it out. So that's right, from Earth. And lastly, we have species. This species is ID 1, human, lifespan of 80. So now we have a little bit of a more complicated API. So kind of what we want to do from here, we can go ahead and show off the ability to generate based off of the OpenAPI spec. So if we go ahead and go, of course it's very to the left. So it's going to have all of your different paths. So you have heroes count, heroes ID friend, all of your different methods. So we'll just go ahead and steal this. Close this out, and here we're going to generate. You know what? I already have it generated. Heroes. So and I just remembered that it is terrible at formatting when you pull it out of here.
You can use the LoopBack command to export.
That's probably a good call.
So,
What was that command? I don't remember off the top of my head. Let's just use the help command. That usually works.
do LB4 OpenAPI-H. This is my favorite song, by the way.
It's not coming from outside, which is weird.
No. It'll validate it for it. Oh wait. Yeah, no. It does. It will not output it. So you have to use the.
LoopBack 3 can do that. Just saying.
So let's just go ahead.
You can turn off your plugin too.
It just. This is what it does, though. I mean, when you formatting is all kinds of messed up, and I don't like it. It's not readable. So now we'll go back to our API generation. Cool. So now we have a Swagger spec. Now if we run OpenAPI, JSON. It'll create all of our controllers for us, both the hero and the paint controller. That's all we built out before. Sure, that's fine. Cool. So now that will have generated for us.
So Jake, just a second. So what you're demonstrating here is we started out by handwriting all the models and controllers and created a Swagger spec, an OpenAPI spec from that. And now you're just showing an alternate way to do it. It's the outside-in approach, correct?
Yes, exactly. Just to kind of showcase what it will actually build out.
Repeat the question for the people at home.
Yes, so he asked if we were kind of showcasing now the outside-in approach that we kind of talked about in the slides earlier, which that is the case. We're kind of showing that you can do things the reverse way, where you start with the OpenAPI spec and build from there. So what we generated, you now have a hero controller. It's got a constructor. It shows you all of the different parameters. But the actual logic is not implemented. Just has all of the operations you had previously.
So it's like partial magic.
Doesn't do it all for you in the same way, but it builds out the model based off of your specification. You have your model, that it does do. Gives you all of your properties.
Can you have it build out a single model, so you want to interface with another API that existed, and you just want to bring in part of those models, so your schemas were all the same internal to your API? Can you partially import?
I mean, if you edit the
Swagger?
file, yeah.
Yeah. Yeah, so if you edited the spec file, you could definitely do that. Or when you generate, I mean, if you're not creating the same controller with the same name, it only generates your models and controllers. So you could just delete your controllers and not use them and just take advantage of the models. The one thing this does differently is it does not define it as the entity like the Swagger spec did, which is a little unfortunate because I would think it would have that ability to kind of
File a bug?
yeah. So that's something that needs to be done eventually.
So just to underscore everything that we've done in the demo here, there's 3 ways, not 4, of writing a Node API. The first is just manually programming everything yourself, which is fine. People have been doing that for decades. So the second way is use the generator to scaffold out a bunch of things for you. I mean, that was the slow way here, but we did it in, what, half an hour? And then the quickest way is take an existing open API spec, import that, and you're like 90% there. You just need to fill in some connections. But I think that's incredible. That's very fast development, and that's going to speed us up a lot. So hopefully you see the value there.
Cool. So now, rather than using the Swagger to generate, that we're going to use it to generate a GraphQL server. So in this repository, we're going to just go ahead and do JSON. Cool. So now we have swagger.json. In order to install OAS Graph, you just do a npm install. I already have it installed, but so I'm gonna skip that. But to run it, you just say OAS Graph and the path to the Swagger.
Make sure the existing server is running.
Doesn't have to be. To start this.
I see.
So it'll start it automatically for you, and it gives you some warnings. So like, we didn't define a response schema for the update. I guess I'll just open up another.
That's something you can add.
Yeah, you can add that in. You can update your Swagger as much as you need to get rid of any warnings you might have. Now we're just
just go ahead and start our normal server. So this server is running, and our OAS graph server is also running. Localhost 3001 GraphQL. So I had been playing with GraphQL already, so we'll just go ahead and get rid of that. So the way GraphQL works is it's query-based, as Craig had mentioned before, but you retrieve only the information you want. So let's start with, I don't know why it's called, that doesn't seem right. Let's see. Yeah, so we got hero, field hero of type hero. Here, let me get you some size there. And still continue to do that, so that this will eventually fit nicely on my screen. This is Craig's fault. Alright, so we have hero. It's going to take in an ID. We'll give it ID 1. And obviously, I mean, you don't want to just get the hero. You want to have some information about it. So we can say we just wanted to know what this hero's name is. Hero ID 1 is named Robin, which I don't think that sounds accurate based off of what the database said. Unless it's querying something different than I thought it was. That might actually be different. We can do this method, which would retrieve all heroes for us. We could do it by, we just want to know their name. Now you see you have Batman, you have Robin, Superman, and we have Wonder Woman. So we have 4 heroes in here. Currently we can get their species ID and their friend ID and planet ID, which would give us the information we need to then call out to the friend or get heroes ID. I think. No, I'm really thinking this first request was friend by friend ID, and this one is actually going to be the wow. So first one returns Robin, second one returns Batman. So this is the actual get hero by ID, and this is the get friend request. So you can kind of filter it down and get whatever information you need. Cool thing we can do with GraphQL is add in a few little links to actually make it easier to connect the way we want. So on our heroes by ID and just regular heroes get methods, if we add these links based off of the ID, it will actually make those second calls for us when we use OAS graph. So if we go into our Swagger spec, which is impossible to find, there we go. So we see our methods, heroes count. It's the ID friend method, which we also do actually need to add operation ID, because unfortunately it doesn't add that for you. So I think that was get friend ID. Get friend by ID, that's what we want. Same thing here. Lastly, species. application itself as opposed to manually editing the swagger?
Yes, you definitely can. I am and now I'm gonna name that one different by ID. Good.
You wrote the app in 30 minutes.
You have to what?
I said you wrote the app in 30 minutes, so
Sure.
it's okay.
Yeah. Now we have heroes ID. So now, under the response schema, right under the reference here, we just go ahead and add these links. Friend will be get friend by ID, get planet by ID, and species by ID. And this will just make sure that we link that. But I added an extra one there, I think. No, I didn't. Cool. So that part's done. Now we just have to do that in one more spot. The heroes get method, which is here. That should actually be tabbed over. Clear that space. Cool. So now we just have to go ahead and restart the GraphQL server. It will reload for us, and now we don't really need to do the species ID thing here. So we can just say, yeah, I guess probably a good idea. So and it is complaining about that, but why is it? Cannot query filled species on type hero.
Just try species ID.
Species ID will not add the, I mean, it'll get you the species ID, but you know, it's naming conventions. You know what, we're gonna look at my history, because I did that in here somewhere. It'll be slightly different, but yeah, so I did it by friend.
The copy and pasting did us in here.
What do you mean copy and paste?
The character versus hero.
Yeah, probably.
It's okay.
I mean it. Make sure I actually saved that. That's not why we aren't seeing anything. Friend, make sure operation ID, response body ID. Yeah, all looks good there. I guess what we can do is, I do know I have it working elsewhere. We can just jump to that one and we'll cheat a little bit. Okay, so let's just do this query will back at that, and ta-da! Now we have it's querying all of our heroes. So you have Batman. His friend ID is number 2. He has a friend named Robin. His species is human. And his planet is Earth.
So based on our OpenAPI spec, we've tied the different models together, and now we're able to use GraphQL in a way different from we would in the REST API, which is now we're able to have nested requests. So inside of a hero, we can ask for the information of a friend and actually get more information about them.
Yeah, or I mean,
or can you get the friend species?
You can. So you can get your friend's species.
Then
I would name. Wait, you can't.
you can. Should we?
I don't think so. Let's just see how this works. I don't know if I tried going that nested.
Too far.
Too far. Yeah.
Or
Does not like that. That's. You can get your friend's species ID. I was like, okay, I know that's a thing. Why is it? I'm not querying pink.
so
Why did that? Oh, that got changed to pink. I don't know how that happened.
So you asked if some difficulties with having 2 different servers on the same node instance, and I think it should be pointed out that LoopBack doesn't recommend that you do that, especially in this GraphQL case. The OS graph is really just like a quick and easy way to spin up a GraphQL server based on the data that you already have. So besides doing the way we just did it, of importing a Swagger file and outputting this GraphQL wrapped server, the other way to do that is programmatically. So you can import some of the OS graph packages and create a server that way, consuming a GraphQL schema. So that's probably the more stable way of doing that, and avoids having 2 separate servers running at the same time that might come in eventually if it's high load or something like that. Might come into some issues. But
Well, the question was, you said it could support multiple servers. Node.js has the cluster capability, but that is clustering based on the number of cores. So that was just really the question, is this really using the underlying node capability?
then I would say yes. Yes, it's all node. Yeah. It's just layers on top of Express on top of node. So yes.
I realized that somehow my first query got changed to ping. I didn't mean to do that, but now I can actually go in and get the friend species, and you could even go ahead and set yourself in a nested loop and get this friend.
You would only go so far.
I'm just
Get all the friends.
yeah, no. I mean, you could just go back and forth for as long as you wanted, really. I mean, being that each of them only has 1 friend, and they're just kind of pointing at each other. But ultimately, you could.
Question on Swagger, I'm aware of what it is, but
Yeah.
not its capabilities. So within Swagger, would you define that schema, data schema for importation, or is that a separate process after you've defined your API?
You can do it inside the code, and you can edit the schema, the file itself.
Right, but you can't do that by definition within Swagger.
Yeah,
Or
you can define all of your models in Swagger, and that can be imported into your LoopBack application, or honestly, a lot of different.
There's different avenues. They make it
Yeah.
very flexible.
Yeah, it's very usable in a lot of different scenarios. We can take a look back at the Swagger, just to kind of give you a little bit of context. So this is going to define your path, what the response is going to look like. It'll define the schema. This is a bad example for the count one, but if we look at the, let's just go to heroes by ID, the GET request is going to return this reference. It points to a schema for hero. So that's going to be all the way at the bottom down here. So you have all of your schema down here. So you have hero, gives it a title, all of your properties. It still defines all of the same things about your models, which makes it really easy to import into your project and start from here or the reverse way. But it definitely gives you a nice way to share your documentation by having this swagger.
There was one other thing we were gonna talk about with OAS Graph. I feel like, am I crazy?
No, I think we covered it. Just the other way of doing it, not the wrapper way. Just
Oh yeah,
automatically.
yeah.
Yeah.
That one there isn't as much documentation on as of right now.
Yeah, it sort of leaves it up to you to implement the server part of that. I think the really fascinating thing about all of this is you have your API spec, it generates a GraphQL schema really quickly. That's the takeaway I want for GraphQL I want you to have. And I think there's really something really interesting here, and I feel like eventually it's gonna catch on. I feel like there's a lot of potential for implementing a GraphQL interface into a Swagger defined system. Cool. So let's wrap up real quick.
Yeah.
That was a lot of information.
Yeah.
And again, all of this is online. You can review later, but just
No, that's the wrong. Sorry, this is now getting out of control.
it's okay. We're good.
Ta-da! We're just gonna click through to the next slide.
Yeah.
Make it easy.
We could take this a step further. There's more to learn. There's plenty more to learn. LoopBack is fairly large, and there's lots of smaller components that we didn't even touch on. So the docs are pretty good, I would say, at explaining everything. One thing worth mentioning is LoopBack Test Lab. That's LoopBack's collection of test utilities that, again, they want to make this really easy to test. So they've basically collected a bunch of tools. So should.js is an expect assertion library that's included in that. They've got sign-on for mocks and stubs. They've got something called shot, which I've never heard of, for HTTP request and response stubs. There's a bunch of utilities for creating super test clients, so you can connect to like a running application in a test environment, and things like API or OpenAPI spec validators. So definitely check that out. Additionally, there's a lot you can do with extensions. I feel like because this is so new, we really haven't seen what we can really do with this yet. So I encourage everyone to go play and experiment and see what you can come up with. There are different types of extensions. There's components. There's decorators, servers, request body parsing. So just off the top of my head, I was thinking of things earlier of what sample extensions we can make out of that. Like a decorator, we could create a circuit breaker extension and basically drop that at the top of a method, and in theory, all of our requests would be wrapped in a circuit breaker. Maybe a good component would be like an OAS, an OpenAPI spec as a data source. So if some other service had a spec, you could consume that inside of your loopback as a data source, and then make requests off of that, off of a model. I think that'd be really useful. And then a server, for example, you can incorporate like Apollo server to get a proper GraphQL server inside of loopback. I think that could be really interesting. So just to recap everything, we went over a lot of the history, kind of what led up to loopback originally, and what its real use case is. So it's that declarative framework to help quickly compose and manage REST APIs as microservices in this case in version 4 using that OpenAPI standard. There's one source of truth to connect web clients to data and services. We went over the key components, things like context and dependency injection, the controllers, the models, and repositories. And we went over the GraphQL and OpenAPI specs and how the OAS graph can translate one into the other to create a very fast GraphQL server. And with that, are there any questions? Again, we just covered a whole lot. Yes, sir.
So,
Can you use Express middleware directly?
The question is, can you use Express middleware directly? And yes, you can. That's really the only easily exposed part of Express that LoopBack leverages. The other pieces like routing you can do, but you may have to create a new server for that, like your own server, because otherwise LoopBack wants you to use their routing composition tools. We kind of touched on it earlier, but there's extensions to middleware that LoopBack provides. They're almost like, I think the old nomenclature was like phases. They were like basically hooks inside of your middleware. So like you can hook into beginning or end of one particular middleware. So it's not the middleware that runs in the order that it was written. It becomes part of a pipeline basically. Yes.
You were talking about MVC, and you said that V is not really a part of LoopBack. Can you expand on that?
Yeah, so it just doesn't expose the view would be the endpoints really. There's no client in this framework, as opposed to LoopBack 3, which when you scaffold it out in the application, you have the option to generate a server or a client or both.
Would you advise against trying to hack in the client into a LoopBack application?
I mean, you definitely could. Whether or not that's a good idea, I'll leave that up to you. I feel like
yeah, that's
We definitely haven't explored it yet.
the idea for this is it's supposed to fit into a microservices context, so it's just one data piece. In theory, your UI would be a whole separate service. So they talk to each other, but they wouldn't necessarily be in the same application. That's when you start getting to that monolith structure that LoopBack 4 is trying to get away from.
Yeah, it just seems like you can prototype stuff out really quickly.
Yeah,
in this, and
Yeah, absolutely.
yeah.
So to continue down that line of thought, I know there's a little bit of experiment with Angular and stuff, being able to import in Swagger docs. So have you experimented at all with having LoopBack, let's say 2 different APIs, both make their Swagger docs, and then have an Angular or some sort of React application and just that to build your controllers and your models on the front end side?
So you're asking if there's some kind of tooling to generate a client library?
So I know there are for Angular.
Sure.
So have you tried though validating that they connect?
No. We have not tried that yet. There's a lot of new concepts here, and LoopBack's still pretty new to us because it was one of those things where it's been talked about for about a year or more, and similar to Angular, where you just don't touch it till it's ready, unless you're actively helping development, because eventually you have to relearn how to do stuff. So we were basically waiting for this to be released. It released in mid-October, and we're really just now starting to get our hands on it. So that's an interesting idea. I think that's worth exploring for sure. You had a question, right?
it was very similar on the
Okay.
MVC.
Great. Yes.
What are some similar frameworks or services that are similar to LoopBack out there?
So similar frameworks to LoopBack. I kind of feel like LoopBack is its own thing. I mean, can you think of any framework similar?
Not really. I don't think I can.
I think traditionally we had just written Express apps.
Yeah. Okay.
And all of our data was managed in a separate way. It was, it was less. What's what I'm trying to say? It was more closely coupled to the data, I guess. And I feel like this gives you a little bit more independence from your data. So So the short answer is no. I don't know many.
The only ones I could think of was like, I know there's some Yeoman generators that would like do your scaffolding for you, but it didn't really couple this closely.
Yeah, this is fairly strict in how what it wants the application to look like. I mean, I'm sure what you saw the file structure looked probably pretty familiar. I know that even front-end applications have a similar directory structure, so they are trying to make things relevant and comparable to things that we already work with. But I can't think of anything that I'm sure there are. I just haven't looked at it yet. Yeah. Any other questions? Cool. Thanks, guys.
All right, thanks guys for coming out. So Craig and Jake and I will be hanging around if anybody has any other questions. And I also wanted to say again, January 17th, next meetup for CI/CD stuff. We'd love to see y'all come back. Thanks for coming.
Good.